Good afternoon. My name is Gureeva. I'm a baccalaureate student at the Great Polytechnic University. I would like to present to your attention my report with the title The Development of an Optical System for Lighting Various Rooms with Sunlight. The efficiency for the person, his well-being, attention, and mood depends on many factors. One of them is the level of illumination and the quality of the light wave. Numerous studies of scientists have shown that sunlight has the most favorable effect on vision and the psyche, but at the same time, when developing lighting sources, the spectral component is often neglected, since the implementation of the full spectrum of the sun is extremely expensive. Currently, only two of the produced light sources fully reflect the spectrum of the sun. Traditional candescent lamp, which has a number of disadvantages associated with a short service life and the possibility of an explosion of the glass bulb, then the spiral burns out. And the lamp consisting of a combination of LEDs of different wavelengths that emit with different power, corresponding to the solar spectrum. The disadvantages of this lamp are the high price and the failure of some LEDs during voltage surges in the network. Therefore, the search for other solutions related to the possibility of using sunlight, especially in residential areas, is extremely relevant at the present time. Let's consider one of the possible solutions, the design of the system of additional natural lighting for residential and working premises, as well as the main one for premises that it's difficult or dangerous to use electricity. It can also be used effectively in the daytime, for example, in long tunnels, in corridors, hangars without windows, etc. A feature of the developed design of the optical system is the presence of a rotating prism. Its use makes it possible to eliminate additional light losses due to reflections on the bands of the light guide, then transmitted it from the collecting lens to the vertical light guide. In the course of an experimental study of light transmission through optical fibers, it was found that the transmitted spectrum is not distorted. As an additional study, we will consider the dependence of the intensity for light entering the premises on the angle at which the light stream enters the light guide. The conducted studies have shown that it's important to take into account the geometry of the roof and the angle at which the optical axis of the focusing lens will be located when implementing the system. The focus of the lens should be located on the outer surface of the light guide. The optical axis of the focusing lens should be perpendicular to the surface of the light guide on which the rotation falls. Further, the bending of the light guide and the number of dividers have a significant impact on the intensity of light entering the premises. Therefore, for each in-zoo lighting project, it's necessary to perform calculations of the system and simulate its operation to determine the optimal configuration for the maximum intensity of light entering the premises. Due to its properties, the developed optical lighting system creates an atmosphere of comfort in residential premises, which contributes to improving efficiency. In addition, energy costs for lighting are reduced. This is the end of my speech. Thank you for your attention.